Hi, in this video we will see how we can convert our non-container database into a container database. And also we want to reuse our non-container database as standby database. That is, we already have a non-container database and it is having a standby database. Now we want to convert this non-container database into a container database and also want to reuse the original standby database of the non-container database. For that, we need to create a container primary database on the same host as of our non-container primary database. And also we need to set up a container standby database on the same host as of our non-container standby database. Further, we need to ensure that these patches are applied on our Oracle home and on the CDB or on the container standby database. We need to set this db create file test to the disk group name, and also db file name convert on our CDB standby should be reset or it is set to null. Further, standby file management parameter should be set to auto in our environments. In our environment, primary host is called the server 5 and server 6 is our standby host. And our non-container primary database is called ORCL19 and its standby is called ORCL STD19. Similarly, our container primary database is ORCC and our containers standby is named as ORCC STD19. In my environment, both of them are sharing the same Oracle home. You can even have different homes for them, but they need to get the same version for this activity. In this activity, we basically reuse the database files of our non-container primary database and also the database files of our non-container standby database when we plug them as a PDB. For that, we need to create ASM aliases or the symbolic link files for our MRP running on the containers standby to be able to identify these files of our non-container standby. After we create the ASM aliases and once the non-container primary and non-container standby are in complete sync, we put this thing in the mount mode and we open this thing in the read-only mode. After opening this thing in the read-only mode, we create a manifest file. And this manifest file contains the location of the database files and other detail of the database files written in XML format. We use the manifest file to plug the non-container primary as a PDB into our container database. Now, since we already created the ASM aliases, the MRP will be able to identify the location of the standby database files through the ASM aliases. Once the MRP on the container standby is able to identify all the database files of our non-container standby database, then we are good to proceed to the next step. That is, we run the non-CDB to PDB.SQL script. On our pluggable database in the primary side. And once all the read is put to our container database and it is in full sync, then we can go ahead and open the pluggable database on our container database. So this way we have plugged our non-container database as a PDB into our pluggable database, and we even reused the non-container standby database files as a standby in our container database. Moving to the practical, server 5 is my primary and server 6 is my standby database. And ORCL19 is my primary database and this is a non-container database. ORCL19 is non-container primary database and its corresponding standby is ORCL STD19 and it is physical standby database. And ORCC is my container primary database. And ORCC STD19 is my containers physical standby database. ORCL19, ORCC, and ORCL STD19 and ORCC STD19. So ORCL19 is my primary, and this is not a container database. This is not a container database, and I have a sample schema HR in it, and HR is having these tables. And ORCC is my container database, and it is having these pluggable databases. It is already having a pluggable database PDB1, and it's a container database ORCC. Now we need to convert this ORCL19 as a pluggable database and plug it into our container database ORCC. And also we want to reuse the standby databases database files. That is, we want to reuse the ORCL STD19's database files while we plug that as a PDB into our ORCC STD19. So let's do the implementation. Further, we have these patches applied in our environment. I have copied the OPatch LS inventory to the notepad. And these are the patches that are required. So I have copied them here. And all other patches are also applied. So all the patches are available on our environment. Verify these two parameters, db create file dest and db file name convert in our containers standby. So on our ORCC container standby, db create file dest is pointing to the disk group name, and also db file name convert parameter is not set to any value, and standby file management is set to auto. We need to run these steps. So from the non-container primary, we need to get the GUID. So this is my GUID. And on the standby system, you need to point your environment to non-CDB standby database and run the script so that it helps you to create the ASM aliases. So this thing prompts you for a few inputs. Enter value for the disk group name without plus sign. My disk group name is data. Enter value for new standby name in uppercase. My new standby is ORCC STD19. It has generated the script alter disk group data, add directory, and then it has given this path to add. And under that path, the next command created the data file directory. This command is prompting us for few inputs. Our old standby name in uppercase is ORCL STD19. and it has generated the ASM aliases for the data files. Alter disk group data, add alias. So it is creating an alias under the ORCC std19 and with the container ID. This is the container ID. So using that under the container ID, it has even created the data file subdirectory. So this path is created earlier. When we run this command, it creates this paths. And under that location, it is creating ASM aliases for the system, sysocs, undo TBS, and users data file, all the data files that belong to my ORCL std19. So it has created the ASM aliases or the symbolic links that will be pointing to the old data files. So I take off the things which are not required in our script. So these are the parts that are required for us to create the symbolic links. We first create the directory and we make use of that GUID, and under that GUID we create the data file subdirectory, and under that data file subdirectory we create the ASM aliases for the existing data files. Now we need to create these aliases as this ASM user by logging into the ASM instance. Before we run this script and create the aliases, we need to verify that there are no other aliases for these data files, and for that I make use of this script. So there are no aliases for the files we are referring to. That is good. Also, there is one more point that we need to understand, that we are creating an alias for the undo TBS. But if your container database is making use of shared undo table space, then this thing is not required. So let's verify if our container database is making use of shared undo or local undo for the pluggable database. For that, I go to my primary. So local undo enabled is true. So we need to have this reference to the undo table space data file also. So we create all these things as CCASM user now. We logged into the ASM instance and we logged in as the CCASM instance. We create these directories. Symbolic link for the system data file. For the system data file, sysocs data file, undo data file, and the users data file. So for all the data files of our non-CDB, we are creating the aliases. Now the MRP on the standby side will be able to identify the database files of our non-CDB standby through the aliases. Once we plug in this non-CDB as a PDB into our container database. When we are ready to plug in, we need to stop the MRP on the non-container standby database. This is our non-container database, and we have stopped the MRP on our non-container database. So once done, we need to create a guaranteed restore point on the containers standby database. It provides the ability to restart the directory search operation on the standby database. So this guaranteed restore point only provides the ability to restart the directory search operation on the CDB standby. We have created those directories a little bit earlier. So let me create this guaranteed restore point. For that, I need to stop the MRP on the containers standby also. I have stopped the MRP. Let me create a guaranteed restore point. So this is my ORCC physical standby. Okay, once the restore point is taken, let me re-enable the MRP. MRP is enabled again. If your environment is making use of TDE, now you need to export your encryption key using this command. And then if at all your environment or your non-CDB standby is in active data guard mode, you need to shut it down. And if it is a rack, you need to bring only one instance in mount mode. Let me bring it into mount mode now. Let me also register with listener. Now we also need to shut down the non-CDB primary cleanly and then restart one instance in mount mode if it is a rack. Or CL19 is my non-CDB primary. Now I am bringing it in mount mode. At this point, flush any remaining redo from the non-CDB primary to the non-CDB standby. So if there is any pending redo, we need to ensure that it is flushed to the non-CDB standby. So all the pending redo is flushed to the standby now. We have disabled the MRP earlier on the non-CDB standby database. So now we open the non-CDB primary in read-only mode. So primary is open in read-only mode. Do not open the primary in read-write mode after this point. If you do this, then you will have to redo some of the steps again. Let's retrieve the checkpoint change from the system data file header on the primary side. So we need to ensure that even on the standby side, till this point all the changes are applied. And for that, we need to run this alter database require manage standby database until change. Till this change we want to run the MRP. Please note that we have stopped the MRP earlier on the non-CDB standby database. So this is my non-CDB standby database and I am recovering it till this checkpoint or this SCN, because my primary is at this SCN. So I want to restore my standby also till this SCN value. So it is altered and now both of them are in complete sync. So let us validate that. So 3585.091 and 3585.091 on both the sides. Now we are good to create the manifest file for the non-CDB primary using this command. So it created the manifest file. So the names of the data files and other details about them. Now we need to shut down the source primary, that is the non-CDB primary, and the source standby, non-CDB standby, ensuring that the source primary should be closed before the source standby. So let's do that. I'm shutting down the source standby, that is the non-CDB standby. I wanted to have a clean shutdown. That's why on a different session, I just brought it up again, verified that the data file header is still at the same point, and then issued a shutdown immediate to have a clean shutdown. Now we are ready to plug the non-CDB ORCL19 as a PDB into our ORCC. For that we need to log into our ORCC container database on the primary side and run this command, create pluggable database ORCL19 using the manifest file. So ORCL19 is plugged on the primary side. Let's verify on the standby side. Okay, we can see data file 13 added to flashback set, and successfully added data file 13 to media recovery, successfully added data file 14, successfully added data file 15, successfully added data file 16. And we can see it is referring to our ASM aliases that we created. So the ORCL19, which is a non-container database, is added as a pluggable database into our container database ORCC, and its standby database is also being reused. So when we plug in, only the database file headers get updated. That is a point to be noted. As we have seen, the data files have been added even on the standby side. We need to proceed further. And the next step would be to run this script on the primary side by connecting to the container that we just plugged in. So this thing takes about an hour in my virtual machine. So I'll just pause the recording and unpause it once that is completed. Okay, this thing completed after a decent amount of time. The script ran fine on the primary. And from a different window, I see the container is available and the archive log list is showing the sequence as 48, and on the standby instance, it has applied all the logs. Let me try to open this pluggable database. So we are able to plug in a non-CDB as a PDB, and we are also able to reuse its standby. We can even open this standby. So we are able to access the data even from the standby. We may have to add a temporary table space on the standby side. Okay, temporary table space also added. If we take a look at the data files, so I am in the pluggable database ORCL19. So this is still referring to the old non-container database files. If you see here, all other database files are in ORCC data file, and ORCC in the GUID of the pluggable database and in that data file. But for the container ID 4, which is ORCL19, which we just plugged in, it is still making use of the data files of the non-container database. And if we check the same thing on the standby database, So these are the soft links or ASM aliases that we created. You can see here users.281 dot, whereas for the aliases it is system underscore 263 underscore sysox underscore 264 underscore. So these are only the aliases that are pointing to the actual database files of the non-container database standby database files. We also have created a guaranteed restore point for the non-containers standby database. We'll have to drop it now. Okay, I am into the ASM instance. So this is the restore point that we have created earlier. We'll have to drop it now. And that concludes our activity. We have plugged in a non-container database as a pluggable database into our container database, and we also reused our non-containers standby database into our containers standby. Thank you for watching.